I hope you are doing well. I spent a long time thinking about how to explain what a protein is, as simply as possible, without losing anyone, without any jargon. And 3 days ago, flash of inspiration at 1 a.m., I found it. I'm going to talk about water. Yes, you heard me right, water. Give me a minute, you will understand. I grew up in a large family, and in my family, school is very important. Knowledge, excellence, hard work, that was the religion of the house. And we had our own vocabulary. When an exam was really easy, we said it was water. Water is simple. Everyone understands it. Everyone knows what is it. On the other hand, when an exam was really hard, I'll save that for another time. So back to water, because I need you to have this image very clearly in your mind before we talk about proteins. So water, everyone knows what is it. H2O. 2 hydrogen, 1 oxygen. That's it. It's small, it's light, it's the most famous molecule in the world. And yet, this tiny molecule can take several forms, depending on the interconnections between molecules. We know the 3 main forms: liquid for drinking or washing, solid for ice, for cooling our drinks, and vapor or steam for cooking. I need to admit that when I think to vapor, to steam, I directly think about a bowl. Does everyone know what a bowl is? A bowl is that soft, fluffy, steamed bun from China. It's delicious. I'm not sure everyone knows what a bowl is, actually. So let's say steam for cooking potatoes. Everyone agrees on that. And a little bonus science note, researchers still discovering fantastic things about water. Japanese scientists recently observed a 4th state of water. It was water confined in nanoscale spaces that was simultaneously solid and liquid. If it is interesting to you, please let me know. I will explain in the next episode. Right? Everyone's clear on water. 3 atoms, several forms. It's simple. And what about proteins? They are also made of atoms, but how many? Are proteins bigger or smaller compared to water molecule? I put here a scheme comparing water molecule to different proteins. On the left, you observe the water molecule, 3 atoms. On the right, an average protein, insulin, one of the smallest. It contains 51 amino acids, meaning hundreds of atoms. And it's not the largest. Look at hemoglobin, thousands of atoms. And the titin, the longest protein in the human body, has more than 38,000 amino acids. The size difference between a water molecule and a large protein is a bit like comparing a marble to a lorry. Now, if we wanted to decompose a protein to see what it's made of, if we enrolled it going in reverse from the 3D structure to something simpler, you can see on the scheme you observe first the 3D shape at the left. It unfolds, then a long chain appears. And if we zoom further on the long chain, we observe that it is made about small repeating units. Those units are called amino acids, the building blocks. And I need to admit that it is exactly at this moment that my 1 a.m. flash of inspiration came back with full force. Have you ever stepped on a Lego in the dark, barefoot, in the middle of the night? Yes, everyone knows exactly what I'm talking about. Those little bricks that end up everywhere. They clip together in every possible direction. That Lego that gets you in the foot at 1 a.m. and wakes up all the house. Well, that might be the best thing that ever happened to you, because that's exactly what is composing a protein. So inside your body, there are tiny molecules called amino acids. Think of them as Lego bricks. There are exactly 20 different forms. 20, that's it. And the protein is simply a long chain of those bricks, clipped together in a very precise order. With those 20 bricks, your body assembles tens of thousands of proteins. It's as if with a single Lego set of 20 pieces, you could build a car, a house, a plane, or even a submarine. And each one would actually work. Of those 20 bricks, 9 are special. Your body cannot make them itself. It has to find them in what you eat. They are called essential amino acids. And that's exactly why everyone talks about consuming proteins, to deliver those 9 bricks to your body, which cannot produce them. Now that we talked about those units constituting the proteins, the chain forming the protein, but a protein is not just a long chain of bricks. And this is where it gets really fascinating. Once the chain is assembled, it folds onto itself. It twists, loops, coils, until it takes a very precise 3-dimension shape. Like a finished Lego build that has a particular form in space. And it's that shape, and only that shape, that determines what the protein does. Its function. Let's take a few examples. Collagen. A twist rope gives strength to your skin and bones. Hemoglobin grabs oxygen in your lungs and carries it to your cells. Insulin, remember just 51 bricks, works as a key that opens your cells to glucose. And antibodies, the Y-shaped molecules, recognize and neutralize viruses. 4 completely different functions, the same 20 brick types, just a different order and shape. Now that we understood what a protein is, what is its composition, how the shape of a protein is formed, constituting its function, let's think about the proteins coming from your nutrition. What happens when you eat a protein, whatever the form is? It can be meat, milk, lentils, egg. Your body cannot absorb it as is. It first dismantle it brick by brick, exactly like taking apart a second-hand Lego to recover the pieces and build something else. The enzymes in your stomach and intestine cut the chain apart. What enter your blood are free amino acids. They travel to the liver, which redistributes them, and your cells use them to build their own proteins, the ones they happen to need right now. What very few people know is that your body renews around 200 to 300 grams of proteins every single day, depending on your weight and muscle mass, even while you sleep. While you eat simply restocks the bricks supply. There are 3 points as takeaway from this video. The first point is a protein is a chain of amino acids, your molecular Lego bricks, that folds into a precise shape. That shape is its function. The second point, 20 brick types, 9 your body can't make itself. What you eat is the restocking. The third point, when you eat a protein, your body takes it apart and builds something else with the bricks. You don't absorb chicken muscle, you absorb the bricks that is constituting it. Next time when you drink a glass of water, 3 atoms, simple and basic, think about what's on your plate, whatever the protein is. Tens of thousands of bricks assembled in a precise shape, keeping your body running. And to come back to the anecdote of the beginning, and as for the hard exam, remember the opposite of water in my family. Well, I will get to that in the next episode, and I can promise that it won't be a water. Thank you and see you then.